back again, back at it with a little bit of algebra action. Chapter 8.1, Monomials and Factoring. This looks slightly familiar down here. Something you're aware of. It's not too hard. Alright, here we go. Let's do this. Okay. A monomial is in factored form when it is expressed as the product of prime numbers and variables. So, if we have 12xy, we'll split 12 into its prime factors, and then x, this is 12 times x times y, and 12 is 2 times 2 times 3 times x times y. So, there we go. That is the factored form right here. Alright? In order to factor a monomial, we're going to factor the coefficient. Now here's something to write down for yourself. Anytime there's a negative, and we did this earlier in the year, anytime there's a negative, you factor that negative with a -1. Okay, so that's -1 times 20. Write that down because I know quite a few of you will forget about the -1. And then 20 factored out. 20 is 4 times 5. Anytime you have a prime that you're done with, you can circle it. So 4 times 5. 5's a prime, so we can circle that one. 4 still needs to be factored, so 4 is 2 times 2. 2 is a prime, and so is 2. Okay, now I've got my primes. I'm going to list these in order from least to greatest. So I'm going to start with -1 times 2 times 2 times 5. Okay, so -1 times 2 times 2 times 5. And now I want to factor out the variables. X to the third means x times x times x, and y squared means y times y. So that is in factored form. It says factor the monomial. This is what I do. Okay, find the greatest common factor. Okay, so I'm going to look at and see what goes into both 12 and 18. One way to do that, and I'll show you a couple ways to do this, one way is to factor both of them. So I'm going to factor 12, that's 3 times 4. 4 is 2 times 2. So, in factored form, this is 2 times 2 times 3 times a times b times c. And then factor 18, that's 3 times 6. 6 is 3 times 2. Put these in order from least to greatest, 2 times 3 times 3, and then times a, and then 3 factors of b. Now I can go through and see what do these have in common. Well, they each have a 2. And then they each have at least 1 3. And they each have an A. And they each have 2 B's. Okay? So my greatest common factor is 2 times 3 times A times B times B. Just the ones that they both have in common. And then I would factor out, this one would have left 2AC. And this one just has 3b left after I've factored out 2 times 3 times a times b. And this, the greatest common factor, simplify that, I get 6ab squared. Okay, another way you can do this is in a type of an upside down division. Okay, I know 12 and 18, I know that 6 goes into both of them. If you recognize that, you can divide them both by 6. Okay, if I divide this by 6, I get 2. The a squared and b squared and c stay. If I divide this by 6, I get 3, and then carry down the a and b to the third. Now I check to see what's the next thing they both have in common variable-wise. They each have an a, so I can divide this by a. And if I divide this by a, my 2 carries down. I'm left with 1a, b squared c. 3 carries down my a. If I divide by a is gone, and then I'm left with b to the third. Now next I'll check to see what else do they have in common. B squared, b to the third. So 2 factors of b is the most they have in common, so I can divide by 2 factors of b, or b squared. Divide this by b squared, and it cancels out the b squared. 2ac is left. Divide this by b squared, I'm left with 3b. And then I look at these two, see do they have anything else in common. Their greatest common factor now is just a 1. So when we're there, we can finish up, say these combined together give me 6ab squared. It's another way of looking at it, so you can pick either one of those ways that works better for you. All right, a florist has 20 roses and 30 tulips to make bouquets. What is the greatest number of identical bouquets that she can make without having any flowers left over? And then how many of each kind of flower will be in each bouquet? All right, which means we need to find the greatest common factor here. Our roses and tulips. 20 roses, 30 tulips. The greatest common factor that goes into both of these is 10. If I divide 20 by 10, I'm left with 2. Divide 30 by 10, I'm left with 3. Now both of these only have a factor of 1. So my greatest common factor is 10, which means I can make 10 bouquets. Now the next question is, how many of each kind of flower will be in each bouquet? Well, if I divide this by 10, split it up into 10 different bouquets, I will have 2 of each of the roses. And if I split this up into 10 bouquets, then I have 3 tulips. And that's about all the fun we will have today. And remember to like and subscribe to the Mastermind channel.